All right, so for today's class, I want to look at the reactions of so we're going to look at the reactions of alcohols, carboxylic acids, and esters. So we already did alkanes and alkenes. We're going to focus on alcohols, carboxylic acid, and esters. And so we're going to start with alcohol. All right, so who can tell me the functional group for the alcohol? Can anybody tell me the functional group for alcohol? So the functional group is the hydroxyl group, which is OH. It's the OH group and it's called hydroxyl. Right, what's the general formula? Anybody remember the general formula for alcohols? Nadine?
CnH2n1OH.
And CnH2n plus 1 OH. That is correct, Mullins. All right. So you must, even though they are pretty straightforward, you must try and remember the functional group and the general formula. So once that is out of the way, we're going to look at naming alcohols. How many carbons are present in this compound?
3.
And so if it's 3, the first part of the name should be what?
Pro.
Pro. Alright. With function, and we're dealing with the alcohol functional group, so the name should end O.
Anal.
That is correct. The propanol. Now we have to tell where the OH group is. And when we're telling which carbon it is attached to, we always count from the end closest to the OH group. So on which carbon would the OH group be present?
First carbon.
Right. So it would be 1-propanol. Or you can put the 1 between the two parts of the name. All right. So propan 1-ol. So you can say 1-propanol, or you can say propan 1-ol. What would be the name of this alcohol?
2-propanol.
Correct. I can write off these two and then we try two more. Is anybody writing at this point? All right.
Yes, sir.
All right. Let me know when you're finished.
I can continue.
Okay. What will be the name of this one now? I think it's still 3 carbons, right? So it would be,
Propanol.
right? Which carbon is the OH group?
First. One.
Right. So if it is on the first carbon, so just like with the alkenes, the OH group it gets the priority. So this would be carbon 1. That means the bromo group is on which carbon? Carbon 2. Right. So it is 2 bromo, 1 propanol. Right. One more. What would be the name of this one? Continue. All right, let's deal with this straight chain first. How many carbons are present?
4.
And if it's 4, it would be? All right, so it's butanol. And which carbon is the OH group?
Second.
Right, so it is 2-butanol. Which other group is present?
Methyl.
Right, so we have a methyl group here. So it's methyl and dash 2-propanol. And which carbon is the methyl group?
Second.
Right. So it is 2-methyl, 2-butanol. Alright. So 2-methyl, 2-butanol.
Sir.
I can continue.
Yes, sir.
All right. Like alkenes and alkanes, alcohols can have isomers as well. So remember, isomers have the same molecular formula, but different structural formula. All right, so let's say of C4H9OH, right? Which alcohol is this? Just look at it. Right. Hold on, repeat.
Sir, butanol.
Right, butanol, because there have 4 carbons.
I can barely see.
So with the marker. No, it's molecular formula, so you want to C4H9OH, they will group all the atoms together. So you will see C, you will see C4H10O, right? C4H10O. So again, remember, if you want an isomer, you draw the 4 carbons in a straight line. All right. We know it's an alcohol, so you can put the OH group on any of the carbons that you wish. All right. So what's the name of this alcohol?
Butanol.
Not just butanol.
One.
Sir, one butanol.
Right. 1 butanol. Now, just like with the alkene, to get a new one, you don't have to break the chain as yet. You can just move the position of the OH group. Right? What is the name of this alcohol?
Two butanol.
Right. 2 butanol, right? So 1 butanol, 2 butanol. Once the position of the functional group is different, they are isomers, right? Now, you could also do what we normally do for alkanes, which is to break the chain. So let us do that one. If we remove this carbon at the end, how many carbons will remain in the chain?
3.
Right? 3. And the carbon that we remove from the end, where must I put it?
In the middle.
Right. You can choose which carbon you want to put the OH group on. So which one do you want to put on? Carbon 1, 2, or 3? Well, carbon 1 or 2. Alright. So what's the name of this compound?
2-methyl-propanol.
Correct. So it's 3 carbons, that's propanol. The OH group is on carbon 2, so it's 2 propanol. And the methyl group is also on carbon 2. Hence, it is 2-methyl, 2-propanol, 2 propanol, and 2-methyl 2-propanol. If the OH group was on this carbon at the end, or even this one at the end, what would have been the name? So if the OH group was on either of these carbon, what would have been the name of the compound?
2-methyl 1-propanol.
That is correct. Right? So for alcohols, if you want isomers, any amount of carbons you get, you just draw them out in a straight line and put the OH group in different positions, and you get different isomers. Also, you can break the chain just like how you did for the alkanes. All right. So it should be pretty straightforward at this point because we did it with alkenes, and now with alcohols. All right. You can take this off and we move on to the reactions of alcohols.
All right, sir. Finish.
And is everybody?
Yes, sir.
All right. Question, what is the name of the reaction in which we get an alcohol from an alkene? How can we get an alcohol from an alkene? What would we add to the alkene? All right, so let us look. So now we are doing the reactions of alcohols. So when you have an alcohol, right, so if you have an alcohol and you remove the OH group and the hydrogen, so OH and H, that is H2O. If you remove it, what will happen is that a double bond will reform. And we would get, which homological series is this?
Alkene.
Right. So if you remove alcohol from the, if you remove water from the alcohol, we get alkene. That means what would happen if you add water to the alkene?
We would get an alcohol.
Right. And what is the name of the reaction? It is called hydration. So when you hydrate an alkene, you get an alcohol. So what do you think the name of the reaction is when we get the alkene from the alcohol?
Sir,
Repeat.
dehydration.
Right, dehydration is correct because to get the alcohol from the alkene, it's hydration, so the reverse is dehydration. And for this reaction, we use a temperature of 170 degrees Celsius and concentrated sulfuric acid. All right. So we will get the alkene. Let me just dry it, below it. So you will get the alkene and water. And this reaction is called dehydration.
Sir, wait there. When you add the water to an alkene,
You get alcohol.
yes.
Right. So the reverse reaction, so water plus alkene gives you the alcohol. And if you remove the water from the alkene, from the alcohol, so if you remove this, that is how you end up with the alkene and the water.
So wait there, the process of removing alcohol.
Right, that is correct.
Right.
Mhm. And so the one with the alkene, when we add the water to the alkene, it will be called hydration.
Right.
Mhm.
Right.
All right. Now, you must also be able to just, so this is a 3 carbon, so it would have been C3H7OH. Same concentrated sulfuric acid heat, and you will get C3H6 plus water. So whatever the scenario is, whether it's displayed formula or just the regular molecular equation, it should not be a problem. Right? So we start with C3H7OH and its dehydration, you should get the alkene. So if it's 3 carbon, you cannot get 2 or 4 carbons. You are forming the corresponding alkene. So you would have to get about 3 carbons. I don't know if the alkene has 3 carbons, it must have 6 hydrogens. All right, plus the water. So the next reaction of alcohol is the reactions of alcohol with sodium metal. All right, so in this reaction, the sodium metal, it displaces the hydrogen that is attached to the oxygen atom. So the sodium metal displaces the hydrogen that is attached to the oxygen atom, and it results in the formation of hydrogen gas. All right. So this reaction, it will produce hydrogen gas. So for this equation, all you have to do is replace the hydrogen with sodium and hydrogen gas as well. Like alkenes and alkenes, alcohol is combustible, so it can ignite, right? It can undergo combustion. What are the products of combustion?
Sir, if it is complete, it is carbon dioxide and water. If it
Correct.
is incomplete, it is hydrogen gas.
No.
No,
Carbon
monoxide.
and water.
And water.
Right. All right, so again, how many carbons do we have here?
2.
So how many do I need here?
2.
All right. How many hydrogens are present? Overall,
6.
right?
With it.
So what number should go here?
3.
All right. How many oxygens do I have here?
4.
And how many do I have here?
3.
That's a total of.
7.
And what did I say about the oxygen in alcohol? What will it do to the total amount of oxygen over here?
-1.
All right, -1, so that is 6.
6.
So 2 times what will give us 6?
3.
Right? And that is our balanced equation. Let's do our next one. Again, how many carbons is here?
3.
So what number goes here?
3.
How many hydrogens in total?
8.
What number goes in front of the hydrogen?
4.
How many oxygen is here?
6.
And how many is here?
4.
That's a total of?
10.
What happens next?
-1.
-1, that is 9.
9.
So what goes here?
9/2.
That is correct. Wonderful. All right. So that's combustion for you. When you're finished, we will look at the other reactions.
Sir?
Ready again?
Yeah.
All right. All right, so the next reaction we're going to do now is the oxidation of alcohols. And the two oxidizing agents we're going to use are potassium dichromate and potassium permanganate. An alcohol react with potassium permanganate. The slash H plus, the H plus means it is acidified, and the acid that we use is sulfuric acid. So we acidify the potassium permanganate with sulfuric acid. All right. We are using acidified potassium permanganate with the alcohol, and the alcohol is going to be oxidized to a carboxylic acid. So whichever alcohol you start out with, you are supposed to get the corresponding carboxylic acid. So if you start out with ethanol, you are supposed to get ethanoic acid. And remember, the functional group for ethanoic acid is COOH, but the displayed formula is carbon, double bond oxygen, single bond OH. So all of this is the functional group for the carboxylic acid. All right. So it's ethanol to ethanoic acid. If it was propanol, you would get propanoic acid. So whatever alcohol you have, you will get the corresponding carboxylic acid. And for this one, the potassium permanganate in terms of observation, so you can say it changes from purple to colorless, or you can say it is decolorized. So whichever one you want to put, it changes from purple to colorless, or you can say it is decolorized. So that is what happens. And as a side note, the reason why you see change from purple to colorless, the oxidation state for Mn, which is manganese. So in KMnO4, it is +7. And in this oxidation state, it is purple. So the manganese is a transition metal. So when they change oxidation state, they tend to change color. So the manganese, when its oxidation number is +7, it is purple. But it is reduced in this reaction to 2+. So when it's Mn2+, it's colorless. All right, so when it's Mn2+, that is when it is colorless. It is going from the +7 oxidation state to the +2 oxidation state. So +7 is purple, +2, but that is when you see change to colorless. It's actually, this reaction is actually a redox reaction. The alcohol is oxidized and the potassium permanganate is reduced. It's a redox reaction. Right. So when you finish, we will look at it again with potassium dichromate. You can do the same reaction, but the oxidizing agent is acidified K2Cr2O7 /H+. It's acidified potassium dichromate. Can anybody tell me the expected color change when we use potassium dichromate? Does anybody know? Nadine or Hilton, Donkey. If potassium dichromate is oxidized, sorry, if it oxidizes the alcohol, what is the typical color change for potassium dichromate? All right, let me remind you, potassium dichromate is orange. So it normally changes to what color? Nobody remembers? All right. It changes from orange to green. For potassium permanganate, it changes from purple to colorless, whereas the dichromate, it changes from orange to green. Just like with the manganese, Mn, just like with manganese, the chromium, it has more than one oxidation state, and when it changes oxidation state, it changes color. So chromium in potassium dichromate, its oxidation state is +6. That is when it is orange. Right? When it oxidizes the alcohol, it is reduced to Cr3 plus. Right? And that is when it is green. So that is why if you see this reaction, it will change from orange to green because the chromium, it is being reduced. So, and you know that reduction is the decrease in oxidation state. So it decreases from +6, where it is orange, to +3, at which point it has a green color. So that is why in this reaction, the potassium dichromate changes from orange to green. So just remember the color changes. Permanganate, purple to colorless. Dichromate, orange to green. All right. It doesn't matter which of these oxidizing agent you use, the reaction is still the same, meaning the alcohol is going to be oxidized to the corresponding carboxylic acid. All right. For this, all you need to remember the color change and the product. If you start out with ethanol, you get ethanoic acid. If it was butanol and we oxidize butanol, which carboxylic acid would we get? If we oxidize butanol, which carboxylic acid? Remember, you're getting the corresponding carboxylic acid. So whichever alcohol you start out with, you get the corresponding one. So if it's methanol, methanoic acid, ethanol, ethanoic acid, propanol, propanoic acid. So if it's butanol, which carboxylic acid would you get?
Butanoic acid.
That is correct. Butanoic acid. Right. Alright, so take off this and then we move to the next reaction.
Ready, sir.
All right. All right, so the next reaction we're going to look at is esterification. Now, esterification is a reaction between alcohols and carboxylic acid. So we start with the carboxylic acid, and then the alcohol. Now for this reaction, right, what we want to do is join both the carboxylic acid and the alcohol together. But the carbon atoms we are joining, so we are supposed to join this carbon atom in red. We're supposed to join this carbon atom in red with this oxygen atom of the alcohol. In order for this carbon atom to be attached to this oxygen atom, we need to get the OH group out of the way, and we need to get the hydrogen out of the way as well. And that is what is going to happen. So in esterification, we need to join the carbon atom of the carboxyl group with the oxygen atom of the hydroxyl group. In order to do that, we need to get rid of the OH from the carboxylic acid and the hydrogen from the hydroxyl group. And when that happens, we can now join the carbon to the oxygen. Right? The line will not be this long. I'm just explaining. Is that clear? So this compound that would be formed now, this would be the ester. Any question? We understand it? Any questions?
Yes,
All right. So that is just remove the OH from the carboxylic acid and the hydrogen from the alcohol and connect them. Right? And so this is our ester. Now the OH and the H, those come together to form, who can tell me?
water.
Correct. So the carboxylic acid, it will react with the alcohol to give you the ester and the water. Now in naming the ester, right, so By the way, if this carboxylic acid has 2 carbons, can someone tell me the name of it? All right, if it's 2 carbon, how would an alkane with 2 carbons start out? Or what would be the first part of the name if it has 2 carbons?
Sir, ethanoic acid.
That is correct. So all carboxylic acid ending anoic, ANOIC. And we know that when we have 2 carbons, it has to be F. So it is ethanoic acid. What is the name of this alcohol with 1 carbon?
Sir,
This alcohol here.
Methanol.
no.
Please repeat. Please repeat.
Methanol.
Correct. Yeah, it's correct. Methanol. Alright. So it's ethanoic acid and methanol. Now, when it forms the ester, the name is going to change. For the alcohol, the anal portion, anal, we're going to replace it with YL. Alright? Put that in that because probably it's a little dull. So replace the anal with YL. So what would it be called now? If you remove anal and add YL, what would the alcohol be called?
Methyl.
Methyl is correct. So when we are naming the ester, remember we have an alcohol portion and we have an acid portion. The acid portion, sorry, the alcohol portion, we are not going to keep all of the name of the alcohol. We remove anal and put YL there. So it is methyl. For the carboxylic acid, right? The OIC, ethanoic, the OIC portion, we're going to remove that portion and replace it with ATE. So the OIC, we're going to replace it with APE. So that means the acid portion, it would be called what? Ethanoate, right, correct. So the acid portion, you remove OIC and replace it with ATE. Go ahead, Kanaya.
Sorry, never say hydroxide.
Please repeat.
Sir, didn't you say you're going to take up
If I said that's something about an ester, Kanaya,
Sir, you're hearing me?
I'm hearing a no.
Sir, asking if you wasn't going to take off the O as well.
Which O? Here? This O?
Yes.
No,
Yes,
no,
sir.
no. Oh, sorry.
Sir, you say OIC.
Yeah, sorry. Just the IC. Sorry about it. Thank you for that correction. All right, so we take off the IC, all right, and add it. All right. So the name of the external, right? The alcohol portion will come first in the name. So if you notice in this structure, it's the acid part, then the alcohol portion. That is the structure for the ester. The acid comes first, then the alcohol. But when you're naming it, the alcohol will appear first in the name. So it is methyl ethanoate. Alright? So that's the name of the ester. So if you react ethanoic acid and methanol, the ester form, it is called methyl ethanoate. We name the alcohol part comes first and the acid portion comes second. But in the chapter, the acid part comes first, then the alcohol. All right.
Sir, how did you get the A star?
Oh, did I get to which part?
ATE.
This? Right, so in naming the ester, it's a rule. So you will have to remove the IC from the acid and replace it with APE. Right? So that is how we end up with ethanoic instead of ethanoic acid. Right? So this chapter is the ester, right? So when you're naming the ester for the acid portion, remove IC and replace it with APE. It's not ethanoic anymore. It is ethanoate. Mhm. Single bond O, that is your extra bond.
Sir, do
Um,
one more. Do one extra.
Except the internet is not available. Right, so, right, I was saying this portion that I just highlighted, C double bond O, single bond O, is called the ester bond. So sometimes you will be asked to highlight the ester bond. So it is C double bond O, single bond O. Alright, so that is their ester bond. Alright, you can try it
Sir,
off
what do you
now.
mean by highlighted? Like what you do on the board just now?
Right, yes, right. So just draw a circle around it or
Circle it
something.
and then label it.
Right. No, if they say highlight it, you don't have
Just circle.
to, right, just circle it.
Okay.
Right.
So you're gonna move on or you're gonna do one next.
I'm going to do that one.
Alright.
Yeah. All right, this time I'm going to use, all right, I'm going to work with ethanoic acid again. All right, so which carboxyl we have ethanoic acid and ethanol. So first, what would if we have ethanoic acid and ethanol, what would be the name of the ester?
Sir, ethyl ethanoic.
That is correct, because we are supposed to remove anol and replace it with YL, and remove IC and replace it with APE. You are correct, ethyl ethanoate. Now, in terms of the structure, right, what must happen to the carboxylic acid? What must be taken off?
H.
Not just OH. Oh, I'm talking the laptop.
And the alcohol at the OH.
Just a second, the battery is dying, so let me remove the arc. Yeah. Try again. No, for the alcohol, it's just the hydrogen that you remove. So just the hydrogen for the alcohol, but the carboxylic acid is the OH. All right. So the oxygen on the alcohol should remain. All right. So it's the one from the acid that comes off. Now, when we're doing the structure for the ester, which one comes first, the acid or the alcohol in the chapter?
Acid.
The acid.
Right,
Alcohol.
the acid, correct. And so if the only thing that is removed from the alcohol is the hydrogen, that means I should have an O here, then C, H2, C, H3. Alright. And as I said, the name of our ester is ethyl ethanoate. And this is our ester bond. And also remember to put plus H2O. Right? Here.
Sir,
Yes, go ahead.
sir, how would you write it if just the C and H, like CH3?
Oh, you mean the condensed formula? Yeah. All right, I'm going to do it. All right, right off this, and then I do it using the condensed formula. All right. So when I finish with this, we do the condensed formula.
Sir, ready.
All right. All right. So we must also look at the fermentation of glucose. So I'm just going to do for this week, just going to do the equation And then next week, we look at procedures for fermentation and soap making. So for fermentation, it's basically anaerobic respiration in which we are making ethanol from glucose. As you know, the formula for glucose, let me just tell you, fermentation. Right, so it's glucose T6H12O6. Right. We're going to make ethanol C2H5OH and carbon dioxide. And the organism we use is yeast. Right? So the yeast will convert the glucose to ethanol, but it's actually an enzyme in yeast that converts the glucose into ethanol. Right? For fermentation, it's just the converting glucose into ethanol and carbon dioxide. All right. But next week we will actually look at the process of fermentation. All right. So that's it for the reactions of alcohol. So we did combustion, that one. We did reaction with sodium metal. We did dehydration, that's 3. Which other one? Is it? Yeah, oxidation, that's 4. Which other one?
Esterification.
Esterification and fermentation. We have 6 reactions of alcohols that you must know. One more thing, it's not in terms of reaction, but in terms of the solubility of alcohols. Just make a note that alcohols are soluble in water because they are polar compounds. Right? The reason why we say alcohols are polar compounds is because of the OH group. Right? So the OH group is what makes alcohol polar. In chemistry, we will go in more details and in terms of polarity, right? But for CSEC, right, we will just say that the OH group is what makes alcohol polar. Water is also a polar compound. I'm not sure if you hear of the term that like dissolves like. So polar compounds will dissolve in polar solvents. Non-polar compound dissolves in non-polar solvents. If you know cooking oil, that's a non-polar compound. Hence, what happens when you put cooking oil in water? Does it dissolve?
Sorry, immerse.
No, exactly right. It's at the top. So because water is polar and oil is non-polar, because we know that that is just carbon and hydrogen. All right. So right. So alcohol, because of the OH group, it is polar. Water is also polar. So that is why alcohols are soluble in water. So alcohols are soluble in water because they are polar compounds due to the OH group. Also, water is a polar compound. Right? Now, if you look at alkenes and alkanes, they will not dissolve in water because alkenes and alkanes are made up of just carbon and hydrogens. So the alkenes and alkanes, they are non-polar. Alright? So there are questions, past paper questions, referring to the solubility of alcohols, carboxylic acids, and alkenes and alkanes. So from time to time, they might ask you why is the alcohol soluble, and either the alkene or the alkane is insoluble in water, and the answer is polarity. So alcohol is polar, alkenes and alkanes are non-polar. Water is polar, right? So for the alkane to dissolve, it would have had to be non-polar because water is polar. If water was non-polar, then the alkene and the alkane would be able to mix with the water, hence dissolving. But because the alkenes and the alkanes are non-polar and water is polar, they don't mix. Is that clear?
Yes, sir.
Right. So that means it will be the same thing for the carboxylic acid, right? With these OH groups, right? So just remember with the carboxylic acid and the alcohol, they are polar, and so they can dissolve in water. For the alkenes and alkanes, they are non-polar, so they do not or will not dissolve in water. Right? So that's it for the, oh, one more thing, the breathalyzer test. What happens if you're driving and you're drunk, right? What, you heard of the breathalyzer test, right? Like when you're
Oh,
drunk,
yes, yes.
or the police want to know if you're drunk. So what they have are the machine, it has potassium dichromate crystals. So if you blow on it, so you're drinking, right? So it's alcohol. So it comes back to reactions of alcohols, it's oxidation. If alcohol is present, right, when you blow on the potassium dichromate crystals, what color change should you observe?
Purple.
It should change from orange to
Wait, they went potassium.
Green.
orange to green is correct.
Sorry, say potassium what?
Potassium dichromate,
Oh, when you breathe
right?
in.
So if you blow on it and changes from orange to green, it means you were drinking. So the alcohol is still present to oxidize the potassium dichromate. There's the breathalyzer test. Let me just check the spelling to make sure. Yes, it's correct. It's the breathalyzer test. So this comes under the oxidation of alcohols. Right? Change it from orange to green. All right, so let's now move to reactions of carboxylic acids. Alright, so as usual, I want the general formula and the functional group to start out with. What's the functional group?
COOH.
COOH, and it's called, what is the name of it?
Carboxylic acid.
No, as in, no, the group is called the carboxyl group. Just like how the OH group is the hydroxyl group, the COOH group, it's called the carboxyl group. All right. And what is the general formula? Anybody?
CN
CNH2.
2N plus
Continue.
HCOH.
1 plus
OH.
plus 1
COOH.
COOH. Right. Remember, all homologous series, their general formula, all of them start with CnH2n. All of them. So CnH2n is a given. With the alcohol and the carboxylic acid, it's plus 1 and their functional group. So every homologous series starts with CnH2n. Then for the carboxylic acid and the alcohol, it's plus 1 functional group. So alcohol, CnH2n plus 1 OH. Carboxylic acid, CnH2n plus 1 COOH. With the alkene, it is just CnH2n. And the alkane is CnH2n plus 2. Alright, so functional group general formula. Let's just name a few. Alright, nothing big. Alright, what would be the name of this carboxylic acid? For the carboxylic acid, when you're counting up the carbons, the carbon of the functional group is a part of the chain as well. So how many carbons are present in the chain? 3. And what is, if it's 3, what would be the first part of the name?
Pro.
Right. So, what is the name now, pro? Finish it. Right, propanoic acid. So, if I put a carbon, not carbon, sorry. So this is propanoic acid, as is. Now, if I replace the hydrogen with a chlorine, what would be the name of it?
Sir,
Mhm.
1-chloropropanoic acid.
Functional group gets the priority. So it would be, if this gets the priority, it means you start counting from here.
So it would be 1, 2, 3, 3
Right.
chloro.
3 chloro propanoic acid. Unlike the alkenes and the alcohols, this functional group, you cannot move it up and down, right? So you won't have like 2 propanoic acid or 3 propanoic acid. It's always at the end, right? So basically, it is always carbon number 1. It cannot be in the middle, right? Along the somewhere in the middle of the chain. So this group is always carbon number 1. So that is why it's 3-chloropropanoic acid. So you always start counting from this group. Alright? Yeah. So that's it for the carboxylic acid. You won't get anything major to name. Alright? So write off this and then we do the reactions. Ready again?
Yes, sir.
All right.
Yes, sir.
All right, so carboxylic acids are just like any other acid. That means they will do the same reaction except for esterification. So the reaction for carboxylic acid, one, we know that acids react with metal to form what? Anybody remember? When acids react with metal, what is formed? All right, so you're going to get a salt and water, not water, hydrogen gas. So magnesium reacts with ethanoic acid. You're going to get, let me just do this. Remember, last week I explained. Anybody remember why I put this in a bracket and the two outside?
Sir, because the charge,
Because,
because of the charge.
right. So the magnesium charge, Mg 2 plus, and the ion there, the ethanoic ion is CH3COO minus. Right? So we know that the 2 would come here. So we have 2 ethanoic ion. So that is where we have to put it in a bracket and the 2 outside. All right? It's a solution. Let me put the state symbol. It's a aqueous plus hydrogen gas. Alright. So when metals react with acid, you get salt and hydrogen gas. Second one, metal oxides, right? So like sodium oxide react with acid, and oxides of metal are bases. So acid and base react, what is formed?
Salt and water.
That is correct. Then you have the metal hydroxides. Again, when acids and base react, what is formed? Salt and water. So whether it's the oxide or the hydroxide, we will get salt and water. Right? Then we move to the carbonate. When carbonates and acid react, anybody know about what is formed?
Salt, carbon dioxide, and water.
That is correct. Wonderful.
Sir, carbonate and water.
Carbon dioxide and water. All right, so we will get CH3COO Na plus carbon dioxide plus water. And then the last one is the hydrogen carbonate. The sodium hydrogen carbonate. It's just like with both the carbonate and hydrogen carbonate, you will get salt, carbon dioxide, and water. Alright. So these are the, apart from esterification, these are the reactions of carboxylic acid that you must remember. And acids in general. So when acids and metal react, salt and hydrogen gas. The metal oxide are the hydroxide, salt and water. Carbonate and hydrogen carbonate, salt, carbon dioxide, and water. Let me know when you're finished. Alright, so I'm actually going to do the esters next week. I'm just going to the next 5 minutes. I'm just going to ask you some multiple choice questions and see how you answer them. For this one, this is from 2016. So we have one alkene right there.
I can write with a different color.
Yes.
You can use a black marker, please.
Or
Black marker dull.
this is finished. So which of these compounds will decolorize potassium permanganate? Which of these compounds can decolorize potassium permanganate? Before you answer it, when we are doing reactions in organic chemistry, the reactions take place at the functional group. For alkanes, carbon to carbon single bond, alkenes, carbon to carbon double bonds, alcohol, OH group, carboxylic acid, COOH group. So, how many different types of homologal series are present here? Based on the functional group present, how many different homologal series do we have from A to D? What are the two of them?
Alkane and alkane.
Right.
And alkane.
Right. Alkane and alkene. No, we have done alkene and alkene. Does both of them react with potassium permanganate? What do you think the answer is? Which one of them reacts with potassium permanganate?
A.
A. And it will have to be A because B, C, and D are all alkanes. And as I said, the reaction takes place at the functional group. So all alkanes, it doesn't matter which alkane, it will do the reactions of alkanes. B, C, and D are alkanes. So all three of them will react alike. That means it has to be the alkane. Remember last week we also said that to differentiate between alkenes and alkanes, we can use potassium permanganate or bromine water. So the answer is A, which is the alkene. Which other compound, which other homologal series can decolorize potassium per alcohol, correct? So the alkenes and the alcohols.
I was looking for that though. It means it's not OH, so it has to be.
Right, because only the alkene and the alcohol can decolorize potassium permanganate. All right. Let us know with which of these substances would an alkane react? All right, and the answer is given of steam, chlorine, hydrogen, steam, chlorine, hydrogen, and the last one, chlorine and hydrogen. Oh, this marker finished now. All right, so which of these will an alkane react? Steam, chlorine, hydrogen, chlorine and hydrogen.
Hydrogen.
All right, so when we did alkanes, we did 3 reactions of alkanes: combustion, cracking, and halogenation. Right? What happened in halogenation of alkanes? What did we react the alkane with? Halogenation also called substitution.
Yes, sir.
What did we?
Is it chlorine?
It is chlorine. Because remember we said that the halogen would substitute a hydrogen. You remember? When I draw the methane.
Oh, I'm getting from but the acid.
Right? I would say that one of the chlorine will replace the hydrogen and the next chlorine would remove the hydrogen, right? Alkanes react with chlorine. It's alkenes that can react with steam or water, right? Hydration of alkenes, hydrogenation of alkenes, halogenation of alkenes. So the alkenes can react with everything here, but the alkane will only react with chlorine, which is a halogen. All right, next one. This marker is really finished. All right. Now you're going to tell me which of these is the functional group for carboxylic acid. There's a B. Which of these is the functional group for carboxylic acid? Wait, no, hold on. This is not right. Oh, wait, yeah, hold on. No, hold on. Yeah, go ahead now. B, right.
The rest of them, they're foolish.
Exactly.
C are alcohol. Everything else from A.
Right.
From B and C are foolishness.
This is a mixture of alkene and alcohol. All right, then now you have to tell me which of these is butene. You must tell me which of these is You have to tell me which of these compounds is butene. Butene,
Oh, alright.
right? Can you see it? Because it does.
Yes, sir. It's a one.
Alright. So that's one compound. I'm leaving off the hydrogens. That's the next one. That's one more. And B. Right? So which one is butene?
B.
B.
Right? Everybody agree with that? Right? Because it's 4 carbons and it's between carbons 2 and 3. And when it gets the lower number, so butene is correct.
Sir,
Right?
what is B?
B?
B and D.
B? No. All right. How many isomers of butane are there? Butane C4H10. How many isomers does it have? We have done this a lot of times. How many?
2.
Right. Right. And the options were 1, 2, 3, and 4. Right. So butane C4H10, it only has 2 isomers, butane and 2-methyl propane. All right, which of the following substances is an unsaturated hydrocarbon? Vinegar, propene, ethanol, natural gas. Which is an unsaturated hydrocarbon? Vinegar, propene, ethanol, natural gas.
So repeat.
All right, remember,
Protein.
propene is correct. Alkenes are unsaturated, remember?
Hydrocarbon.
And alkanes are what? Alkanes are?
Saturated.
Saturated.
That is correct. So the answer is propene. All right, so let me just erase this.
So we're going to have class during CXE.
Yes, going to do it straight up to exams. All right, so A, I'm just going to put the functional group. A is an alcohol, B is an alkene, B is an alkene, C, C3H8, let me put it as is. C3H8, B is C3. Let me try the red. The red much over than this. Not seeing this? I can't see this. C3H8. And this is C3H8. All right, B is an ester. Let me just write big, hopefully. So CH3, COO, C2H5. Right? So the question now, which of these substances is a saturated hydrocarbon? Which of these is a,
C.
right? Because C is the alkane, right? Then it says, which of the substances is a compound that is soluble in water? So which of these is?
No. A.
Right,
Alcohol.
right. Because it said alcohols are carboxylic acid. So that is correct. And then, which of the following substances? Let me ask it already. The other one is about polymers. So we did that already. Did that. Which two of the following phrases correctly describe the compound? Right. So for this question, it's about an alcohol, and it is asking which of the phrases is correct about the alcohol. Oh, well, it has the functional group OH. So once you see the OH, we know it's an alcohol. All right. So phrase one said it's an alcohol, so we know that that is true. Reactive with sodium. We know that alcohol is reactive with sodium, right?
Yes, sir.
Right. It says not reactive with acidified potassium dichromate. Does alcohol, and we know alcohol react with potassium dichromate, right?
Yes,
Yes,
sir.
sir.
Right. And the other option said it was a branched alkane, which would not be the case. So we know it's an alcohol and that it is reactive with sodium. All
Sir,
right.
what was the question again? True or false?
No. So it had done, it was a the compound. So it was CH3, C, CH2OH, CH3, CH2, CH3. Right. So they are given this compound, and we must choose two statements that are correct. So the first statement said it is an alcohol. So is this compound an alcohol?
Yes, sir.
All right. So statement one is correct. Statement two says this compound is a branched alkane. Is this compound an alkane?
No.
No, sir.
Right. So statement two is false. Statement three says this compound is reactive with sodium. Is it?
Yes, sir.
Yes, sir.
Right. Because it's an alcohol. And the final statement says it is not reactive with acidified potassium dichromate. Is that correct?
No, sir.
Right. Because we know that alcohols are oxidized by potassium dichromate. All right. Let me see. There's one more. It says, which of the following substances is a product of a halogenation reaction with methane? Before I read out the answers, right? In the halogenation of methane, when chlorine replaces a hydrogen, right? And you get the chloromethane or whatever alkane. Which other product we always get?
Say I will
Hi,
get
hydrogen.
hydrochloride.
Hydrogen chloride,
Yes.
right? Remember, one of the chlorine always takes off a hydrogen. So we get hydrogen chloride, right? So in the halogenation reaction with methane, which of these substances are produced? A, ammonia, is that correct?
No.
Two is water, B is water, is that correct?
No, sir.
No.
C, hydrogen chloride,
Yep.
right? Then the last one, it says, which of the following statements about compounds in a whole molecular series are correct? All right. So now, whole compounds in a whole molecular series, it's the first one says they exist in the same state. No. It says, which of the following is correct? All right. So some characteristics of compounds in a whole molecular series, they have the same functional group, they have the same general formula, they have similar chemical properties, right? But in terms of physical properties, as the amount of carbon increases, the physical properties change. So like for the alkanes, right, it will start out as a gas, right? But as it increases, everything changes, not just for alkanes. So the melting point, boiling point, density, everything changes. So the physical properties are not the same as the physical state, right? So as the number of carbon increases in the whole molecular series, the physical property, it changes, right? And they also, the compounds differ by a CH2 group. Next week class, I will just write a list on the board. So, right, back to it now. It says, so we are looking for the one that is correct. So the first one says they exist in the same state. Now, as I just said, as the number of carbon increases, they will change state from, if it's alkane, it will go from gas to liquid. All right? Now it says they possess only carbon atoms in straight chains. They possess only carbon in straight chains. We know that carbons can be branched, right? Like when we're doing isomers and we branch them, right? So we know they don't have to exist in straight chains. Then it says they possess the same empirical formula. No, the empirical formula can change. And the last one, they differ by a successive CH2 group. That one is correct. So the marker is a bit dull, but if you look at propane, let's look at that one. They differ by a successive CH2 group, right? Like for propane, it is CH3, CH2, CH3, right? If you go to butane, it is CH3, CH2, CH2, CH3, right? And if you go to pentane, so look, one CH2 group in the middle, right? For propane. If you notice, butane have how many CH2 groups?
So what are two?
Right. CH3, CH2, CH2, CH3. That's butane. If we do pentane, it would have three CH2 groups, right?
Yes, sir.
Right. So that is what it is saying. Each successive one differs by a CH2 group. Right? So I'm going to end it here for tonight. So next week we finish off with organic chemistry by doing esters and polymers. All right. So next week we finish with organic chem. Then we will do electrolysis and go and just pick off the topics that are coming one by one. All right. So that is it for this week's class.
Sir, don't leave it. Don't leave it.
Oh, by the way, for those of you, if you're joining for the first time and you want to, because I'm going to upload it to the channel. So it is, if you want to watch it, it is Mr. Here's Chemistry Lecture Series. All right, so I'm going to upload it to this YouTube channel. Just click on playlist and look for CSEC Chemistry Revision or something like that. But just go in the playlist section and look for CSEC Revision or something like that, and you will find it. Go ahead, Kanaya. It was who wanted to ask a question.
Me, sir.
All right.
Sir, for the qualitative analysis, let me see them say we are good.
Right.
You go find that, teach on find that.
Repeat.
I say if you're going to teach on find that.
I'm going to do everything that is coming on the exam.
Oh, alright, sir.
Yeah.
Another thing about, another thing.
Yeah, man.
In the group, Mr. Then send a message for 10 to 2.
Welcome.